Many believe that space is entirely silent. After all, sound waves need something to travel through, like air or water. In the vacuum of space, there's practically nothing for sound waves to vibrate. This leads to the common misconception that rockets roar through the cosmos, planets collide in deafening silence, and stars explode without a whisper. However, the reality is far more intriguing. While traditional sound waves can't journey through the emptiness of space, space isn't actually empty. It's teeming with other forms of energy and matter that we can't always see. Imagine a vast invisible ocean, and instead of water, it's filled with magnetic fields, plasma, and radiation. These elements, though invisible to the human eye, carry vibrations and disturbances much like ripples in a pond. They hold the potential for sound, even if our ears can't directly perceive them. So while space might be silent to our ears, it's certainly not devoid of activity. There's a whole symphony of cosmic sounds waiting to be heard if we know how to listen. Let's delve into this cosmic orchestra. Imagine a giant magnetic field like the one surrounding our Earth. These fields are constantly in motion, interacting with charged particles from the sun, also known as solar wind. This interaction creates disturbances like invisible waves crashing on an invisible shore. These disturbances are not sound waves in the traditional sense. They don't vibrate the air and reach our eardrums. Instead, they're fluctuations in the magnetic field itself, carrying energy and information across vast distances. Think of it like the vibrations you feel when you hold a balloon close to a speaker playing loud music. Similarly, plasma, a superheated state of matter found throughout the universe, also vibrates and oscillates. Picture a pot of boiling water, except instead of water molecules, we're talking about charged particles moving at incredible speeds. These movements create pressure waves that travel through the plasma, much like sound waves travel through air. These magnetic and plasma waves hold valuable clues about the universe. They can tell us about the composition, density, and temperature of distant stars and galaxies. But how do we decipher this cosmic symphony? That's where NASA's ingenuity comes in. NASA utilizes specialized instruments both on Earth and in space to capture these invisible vibrations. These instruments act like cosmic microphones, detecting the subtle fluctuations in magnetic fields and plasma waves. One such instrument is attached to the Voyager spacecraft, billions of miles away, listening to the whispers of interstellar space. Once captured, these signals are transmitted back to Earth as data. However, this data isn't in a format that we can readily hear. It's a jumble of numbers and graphs representing the complex patterns of these cosmic vibrations. This is where the magic of technology truly shines. Scientists and engineers develop sophisticated algorithms and software to process this raw data. They convert these abstract measurements of magnetic fluctuations and plasma waves into sound waves that our ears can perceive. This process is similar to how a radio translates radio waves into the music we hear, making the invisible audible. Section 4. Echoes from a black hole. One of the most captivating examples of this technology in action is the sonification of a black hole. In 2003, astronomers discovered that the supermassive black hole at the center of the Perseus galaxy cluster was creating pressure waves in the surrounding hot gas. These waves, with a frequency millions of billions of times lower than what humans can hear, were essentially the sound of a black hole. Using data from NASA's Chandra X-ray Observatory, scientists translated these pressure waves, scaling them up to a frequency audible to humans. The result was a haunting low-frequency hum, a sound unlike anything heard on Earth, echoing through the vastness of space for billions of years. This sonification, though eerie, provided valuable insights into the behavior of black holes, their impact on surrounding galaxies, and the fundamental nature of gravity itself. It demonstrated the profound ability of sound to convey complex scientific information in a way that visuals alone cannot. Section 5. Listening to the Secrets of Space. By transforming invisible cosmic vibrations into audible sounds, we're not just satisfying our curiosity about the universe's hidden symphony, These sounds are invaluable tools for scientific discovery. They allow us to study objects and phenomena in space that are too distant, too faint, or too obscured for traditional telescopes. Each crackle, hiss, and whistle from these sonified datasets tells a story. They reveal the secrets of star birth and death, the dance of galaxies, and the echoes of the universe's earliest moments. As we continue to refine our ability to listen to the cosmos, we open new avenues for understanding our place in the universe. So the next time you gaze upon a silent, star-filled sky, remember that the universe is far from quiet. It's alive with a symphony of sound, a cosmic orchestra playing out across unimaginable distances, waiting for us to tune in and listen.